allot some time to talk about yung past activity natin, which is the quiz. Okay? In which I would like to take note na, or I would like you to be known na na-scan ko yung mga pinasa ninyo. Okay? And as far as I am concerned, yung ilan sa mga naipasa ninyo, or some of the things that you have submitted, we're not in compliance with the guidelines that I have set. Okay? So I don't know kung ano yung reasons niyo on not complying. Okay? Pero i-address natin 'yan. Okay? I mean, when I say address, I would like it to be known na I don't take this non-compliance lightly. So which means for this at this particular quiz, okay, since this is the first quiz that you have experienced, okay. Yung mga non-compliance natin, nagkakaroon siya ng mga deductions. Okay. And maliit lang naman. Sa ngayon, we'll put it at of course the deductions is per item. Okay. Dahil per item din naman yung natin. Okay. Pero in every non-compliance, bibigyan natin siya ng deduction na 1 point. For this particular quiz, quiz 1. Okay. Pero pag quiz 2, lalakihan na natin yan. Okay. Lalakihan na natin yung deductions yan. So, you might be wondering, sir, bakit may mga deductions yung mga non-compliance? Number 1, following instructions yun eh. Okay? You were instructed to do a certain thing in a certain manner, pero hindi nyo ginawa, okay? Or hindi nyo na-comply. Okay? And whatever reason you may have, okay? You may have because that led to that non-compliance. Should be addressed. For example, isa sa mga common. Okay. 7 lang kasi kayo, so hindi ko masabing marami eh. Pero for example, sa isang question that all of you were able to answer. Okay. Sa isang question na 7 kayo nakasagot, nagpasa kayo ng sagot. 3 doon hindi nakasunod sa file name. Okay? Meron tayong prescribed na file name, di ba? There is a prescribed file name. Na nyo ba yun? Na-pick up nyo ba yun? Na merong prescribed file name. Or aware ba kayo na merong prescribed file name para sa answer sheets na ipapasa ninyo? Hindi kayo aware? Wala nang kataas ng kamay. So, hindi kayo aware. Yung walang nagre-react, I'll consider. Okay, so aware. Okay, kung aware, yun na nga. Pero, ibig sabihin non-compliance nga yun. So, ibig sabihin, we will have to address that by making sure that you remember it. Okay. And maalala niyo yun in a manner na nagkaroon ako ng deductions dahil sa simpleng bagay lang na yun. Okay. So, again, ang kasi dyan is kung hindi nyo maayos yung simpleng report na pinagagawa sa inyo, simpleng instruction na pinagagawa sa inyo, hindi nyo magagawa yung mas malaking bagay. That's one thing that I would like you to learn. Okay, from me at least. Na yung mga little things with regards sa pagsusulat ng report. Okay, is something that you would have to work on. Okay, kahit na maliit na bagay lang yan. Again, kung yung isang maliit na bagay hindi nyo maayos, mahirapan din kayo maayos yung malaking bagay na may assign sa inyo. That's one thing that you have to remember. Okay. That's number 1. Okay. Number 2, I would also like you to temper your expectations when it comes to the score that you might have. Okay. Baka kasi bilang nyo na kung ilan yung score nyo. Okay. And baka you were thinking that marami ako nasagutan, so feeling ko mataas ako. Okay. Kasi I was reading some of your work, some of your reports. Ang instruction ko, okay, ang instruction ko is for you to explain, to discuss your work. Kung problem solving yan, you have to discuss your work fully. Okay? I need discussions in your report. In your report. Hindi tama yung for example, merong isang instance na nagbigay siya ng equation. Binigay niya yung equation ng electrical network. Tapos bigla siyang tumalon sa I2, for example. Hindi niya sinabi paano nakuha yung I2. So, yung proseso na yun. I mean, I'm not privy kung ano yung alam nyo at hindi nyo alam. Okay. Malay ko ba na na master kayo ng algebra at makita nyo lang yung makita nyo lang yung isang equation. Kuha nyo na yung sagot, no? Okay, pero hindi kasi ganun nag-work yun. Dahil ako, hindi ko alam yun. I mean, I don't know that about you. Okay, I don't know about, I don't know those kinds of, those kinds of details about you. So therefore, if those are missing in your report, okay, I would construe it na, na it's either hindi nyo alam or you are making hula. And that should work, and that would work against your that would work against your ability or your campaign, kumbaga, to get a high score in a certain question. Okay, so dali lang, yung aso kasi maingay. Ayun, ang pinopoint ko is that hindi dahil sa nakuha nyo yung tamang sagot, hindi dahil sa nakuha nyo yung tamang sagot, okay na kayo. Okay? I was asking you to provide me evidence that you know what you are doing. And if those evidence and if your report lacks those evidence, then hindi niyo makukuha yung report, hindi mo makukuha yung score kahit na tama yung sagot niyo. Okay? As I am pointing out with you over and over again, simula pa lang ng orientation, yung binigay ko sa inyong report, yung guidelines on how to write your report, pati yung guidelines na binasa ko bago kayo mag-quiz. Okay? In all those I am encouraging you to provide evidences that you know something. Okay? That you know something something about what you are trying to present. It's not enough na pinapresent niyo lang yung sagot. Because tapos na tayo sa ganung era na nag-aano lang tayo ng tamang sagot. Okay? Maaring tama yung sagot nyo, pero kung hindi nyo naman mai-present ng maayos, hindi rin mai-score ng tama yan. Dahil ang ini-score natin is achievement ng outcomes. And kailangan bigyan nyo ako ng ebidensya, ng solid evidence that you are achieving these outcomes. So, ito i-temper nyo yung expectation nyo when it comes to scores. Dahil baka magkagulatan kayo na baka madami naman akong sagot pero bakit ganun yung score ko. Okay. Anyway, the good thing about teams is that ang mangyayari yan is ganito. Pag na-checkan ko na yung papel niyo, I have the option to return your paper, your work to you. Okay? So, hindi ko lang alam kung paano yung presentation ng teams, no? I don't know how teams would actually present that. Pero from what I understand is that yung papers niyo that yung sinabit niyo sa akin na merong feedback ko, okay, which I would be able to write. Kaya nga sa Word ko siya pinalagay kasi I am planning to write feedbacks. Okay, I am planning to write feedbacks. Tapos para yun din yung i-return ko sa inyo. Okay? Yun din yung i-return ko sa inyong paper. Okay? So, you would be seeing this kinds of feedbacks from me. Okay? Para doon sa quiz na yun. And hopefully, I would be able to work on your papers. Kasi considering na binibilang ko kung ilan yung total number of students ko. Kasi kung alam niyo naman na ang protocol ko is sabay-sabay ako nagpapa-quiz sa lahat ng klase ko, lahat ng lecture classes ko. So in this particular term, I have three lecture classes and 3 laboratory classes. So yung tatlong lecture classes na yon, dalawa doon control systems. So kayo tsaka yung isang section ng control system. So 7 kayo plus 11 sa kabilang klase. So 18 students lang ako sa control system. Pero yung isa ko kasi is yung advanced math. Nasa 20 plus sila, 25, 26 mga ganun, 29 mga ganun. So all in all, meron akong 40 plus students for lecture classes. Okay. Feeling ko mas madali ko siya mati-checkin ngayon kasi kumpara last term was I only have 2 lecture classes last term pero meron akong 60 plus na students. Okay, so medyo nahirapan ako mag-check last term. Kaya ayun. Pero ngayon, since 40 plus lang kayo, even though dalawang courses yung checkan ko, I think magagawa ko na checkan yung papers niyo by and I would be able to give meaningful feedbacks. Okay. So hopefully ganito ang iniisip ko scenario kasi hindi ko pa na-try din to dahil last term hindi ko na-return yung mga papers ng mga students ko. So tsaka isa pa, hindi ko rin siya ma-return dahil I had them write their report tapos pina-PDF ko. Okay. Ang problema pala pag pina-PDF ko, hindi ko siya mabuksan ng hindi ko siya mabubuksan directly sa OneDrive. Tapos may edit ko siya sa OneDrive. Ang mangyayari is that kailangan kong i-download yung paper. Okay? Kailangan kong i-download yung paper. Tapos i-ano ko siya, gagawan ko ng feedback. Okay, i-checkan ko. Tapos gagawan ko ng feedback. Tapos kapag binalik ko kasi, nawawala na yung connection. So parang kapag ni-return ko siya, hindi rin nakikita ng students yung yung paper nila. So sayang lang din yung effort. Kaya ngayon ginawa ko, hindi ko na pina-convert sa PDF. Word na lang yung pinapasa ko. So ayun. So ito yung scenario na nakikita ko, I would be able to return your papers pagkatapos ko na siyang ma-checkan. Okay? May feedback ako nakalagay doon. Reflect on the feedback. Okay? Reflect on the feedback that I would be writing. Okay? And make improvements in the next although yung topics in terms of topics, makakabawi na kayo sa final exams na yun. Kasi mako-cover ulit yung mga questions, yung mga topics that are covered in quiz 1. Ang bawi na niyan, final exams na. So, at least may gamit pa rin. Okay, magagamit niyo pa rin yung natutunan niyo dun sa quiz 1 and together with my feedback sa isa pang actually sa mas mahalagang assessment which is the final exams. Okay? Pero yung iba, the other things, okay, can be used sa quiz number 2. Okay? So, and speaking of which, ang schedule natin ng quiz number 2 ay kailan? February 24. So the next quiz is scheduled February 24. That's less than 3 weeks from now. So parang dalawang Tuesday yung tatlong Tuesday yung dadaan at dalawang Friday. Tama ba? Tama ba ako doon? Sige, bukas tayo ng calendar.
Tatlong Friday natin, sir.
Tatlong Friday kasama to.
Tatlo, sir.
Sa tatlong Friday, tatlong Tuesday. Kasama to ha, itong Friday na to. So, ayun. Ito yung 24. So, isa, dalawa, tatlong Friday, tsaka tatlong Tuesday yung dadaan. Okay, so ganito. I'll be assigning kasi ito yung quiz nyo. So I'll be assigning 3 homeworks for you. Supposedly tapos na tayong topic 4 kasi inaral niyo na dapat yung topic 4 dun sa recorded lecture. And ito ang problema nito ha. Ako ang expectation ko talaga is inaaral niyo yung binibigay ko sa inyong mga materials. So ngayon, ang didiscuss ko actually ngayon kasi is topic 5. Okay? Ang topic 5, yung topic 5, kailangan niyo ng knowledge yung topic 4 kasi magkadugtong na topic yan, topic 4 and topic 5. Okay? So magkadugtong yan. So therefore, dapat alam niyo kung ano yung nasa topic 4. Dahil kapag hindi niyo alam kung ano nasa topic 4, hindi niyo maintindihan yung topic 5. Okay? So ang expectation ko ngayon is ganun ha. Pagka may inassign sa inyong reading na meron kasamang recorded lecture, ang assumption is aaralin niyo siya talaga. Okay? And ayun. And again, sinasabi ko naman sa inyo kung meron kayong question about the lessons, i-message niyo lang ako. Okay? So kung nahihirapan kayo sa isang part ng topic na pinapara sa inyo, ang expectation is itanong niyo lang. Okay? Pero so far wala kasi ako natatanggap na concern. So ang expectation ko naman is okay na kayo. Okay, so ayun. So I'll be assigning topics 5, 6 and 7. Okay? Hindi ko pa nalalagay dito hindi ko pa nalalagay dito sa content library. Pero siguro probably tonight or tomorrow morning. Okay? I-assign ko siya sa inyo. Including homeworks 5, 6, 7. Okay? So, i-assign ko siya sa inyo. Yun ang magiging coverage ng quiz number 2 natin. Okay? So, clear tayo doon?
Yes, sir.
Yes, sir.
Okay, so sige. So those are the things that I would like you to remember. Okay. So we'll proceed now with the discussion. First discussion sa topic 5. Okay, which is ang topic 5 nyo kasi covers underdamped systems. Okay? So little review. Feeling ko kailangan ko ng baguhin ito. I mean, here's the thing kasi, tawag ito. Yung kapag may mga gantong ginagawa ng mga course materials, pag yung format niya hindi parang overtime kasi nagkakaroon ako ng ways para magawa tong mga materials na to. Uy. May fries ako. Thank you. Ayun. May nagbigay sa akin ng fries. Okay, so ang sinasabi ko habang tumatagal tayo dito, nagkakaroon ako ng ways para magkano. So, meron ako parang certain format na sinusunod. So sa ngayon, nakikita ko to, hindi na siya yung format na ginagamit ko dun sa dine-develop kong ibang course material. So naiilang na ako. Gumagana yung pagka obsessive compulsive ko. Okay, so anyway, so ito na lang Wag niyo na masyadong pansinin na 3 ito tapos 5 yung Supposedly kasi dapat match yan Kung to, dapat yun din yung equation number. Okay, anyway, i-correct ko na lang to sa susunod. Picture pa naman to. So hindi talaga siya mako-correct. Unless iyan ako talaga siya. Anyway, so sige. So we review muna. Also, kung mapapansin nyo, ibang version ng OneNote ang ginagamit ko. This is OneNote for Windows 10. Tawag dito. Kinuha ko to sa Microsoft Store. Kung naaalala nyo, nung mga past mga na synchronous sessions natin, minsan nahihirapan ako magsulat dahil hindi nagmi-miss yung yung writing tablet ko. Parang, halimbawa, pag nagsulat ako ng C, ang lumalabas ganito. So, naiinis kasi ako. Ngayon na-discover ko na hindi pala siya dahil sa mabagal yung PC ko or may problema yung tablet ko. Ang problema pala, yung mismong OneNote. Kasi dito hindi siya nangyayari. Okay, so ayun. If you can find this sa Microsoft Store, OneNote for Windows 10. Mas slick kasi yung design niya kumpara doon sa isa. Although, ang maganda naman doon sa isang app, nakakapag-export kasi ng materials. Ibig sabihin, pwede nyo siyang i-export as PDF, for example. Ito kasi hindi pwede. Wala siyang ganung feature. Anyway, so review ko lang ng konti yung sa topic 4. So dun sa topic 4, diniscuss dun yung it was discussed in topic 4, the response, okay, of first order at saka response of second order. When you say first order at saka second order, ano yung tinutukoy nito? To what concept does this terms refer to? Yung first order at saka second order.
Sir, ano ba yan? Yung f of t at saka f of s?
Those are the yung f of t is the function in time. Yung f of s yung Laplace transform niya. So itong dalawa to actually has something to do with f of s. Pero bukod doon, this first order or second order actually somewhat has something to do with f of s. Or in general, it actually refers to the transfer function. Okay? G of s. Pero ano talaga yung specific na sinasabi niya about g of s? Or about your transfer function? Kaya tayo. Anyone? Guys, sandali lang ako. Wala ako ng water. Wala pala akong water dito. Sandali lang. At pag-isipan nyo, natanong ko Wait lang. Okay. Yung first order tsaka yung second order, saan tumutukoy yan? Or ano yung sinasabi, what does it say about G of s?
Sa ano ba yan, sir? Sa initial condition and equilibrium?
Hindi. Medyo medyo off na siya. Medyo off na siya yung yung initial conditions. Kasi here's the thing. The thing about this this discussions that we are having is ang discussion natin actually sumasakop lang siya, or yung scope ng discussion natin is all on systems that has no initial conditions. So lahat ng pinag-uusapan nating systems dito are basically relaxed. They don't have initial conditions. Yun yung kaya out of
so basically
out of scope yung wait lang out of scope yung yung initial condition dahil lahat ng pinag-uusapan nating system has no initial conditions. So sige, ano sinasabi mo?
Ano sir, basically parang steady state, sir, ganun?
Hindi. At rest yung system, pero it doesn't mean na steady state kagad siya kasi ang system that at rest, pag ginalaw mo, magre-react pa yan bago siya mag-steady state.
Okay, sir.
Ganun na nangyayari sa system natin. Kahit naman sa kahit sino. Ang isang for example, kung kayo at rest kayo, say nakaupo lang kayo. Okay. Pag may tumulak sa inyo sa likod, for example, hindi naman kayo kagad hindi naman kayo kagad mapupunta sa isang position. Sa isang resting position agad. Mapupunta muna kayo sa isang position na out of your resting position, tapos tsaka lang kayo babalik. For example, pag tinulak kayo sa palikod, gaganto muna kayo bago kayo bumalik dun sa resting position niyo. So, ganun yung nangyayari sa atin. Anyone? Thank you, Mr. Francisco, sa mga share mo. Okay. Pero anyway, ano yung tinutukoy niya dun sa GFS natin? Napag-aralan niyo ba yung poles and zeros? Nadaanan niyo ba yan?
Yes po, sir.
O, ano yung poles?
Ano po siya, nasagutan po sa assignment po.
Yeah, pero paano natin define yung poles? How were poles defined? Sorry, medyo gutom na rin ako. Habang nitig ko kayo sumagot. Go. How did you define poles?
Yun ba sir yung poles and zeros sa sa denominator at numerator sir ng transfer function?
Has something to do with that. Pero specifically, ano yung poles? Una, saan natin sinusolve ang poles? Sa transfer function, saan natin kinukuha yung poles? Ano yan? It has something to do with that. Tama yan. Pero sa natin specifically, kinukuha ang poles, sa natin specifically, kinukuha ang zeros. Ayun, medyo malapit ka na. O, diba? Itong mga discussion na to, nasa ano to ha? Nasa topic 4 ito. This is under topic 4. Na-discuss ko yan doon sa recorded lecture ninyo.
Sir, yung zeros ba, yun ba yung nasa numerator na kunwari S-1? Yung
This is the...
poles of 1?
Yeah, yan, tama yun. Sabi ni Mr. Francisco, kung for example, if the numerator of your transfer function is S-1, halimbawa, is S-1, yung zeros mo ay, or yung zero mo in this case is, Mr. Francisco?
1, sir.
1, okay. Ang tawag natin dyan, root. Okay? Because we will basically have to equate that S-1. We will basically have to equate that S-1 to 0. Okay? Or basically, when you have a transfer function G of S equals your G of S, it's basically a rational function. Ns over Ts. Okay? So may numerator polynomial yan and may denominator polynomial yan. Okay? So that for us to be able to determine the zeros, we will have to look for the roots of the numerator of the transfer function. So that would be the zeros of your system. Or tawag natin ito system zero o system zeros. Because we are solving for the roots of the numerator of your system function o system transfer function. So system zeros ang tawag natin doon. O simply zeros na lang. So, ang gagawin natin para ma-solve natin yung roots ng numerator of G of S niyo, you would have to equate the numerator function to 0 and then solve for S. So that would be your zeros. How about your poles?
Sir, roots of the denominator na yun, sir.
Okay. Of G of S. That is, we equate now the denominator function to 0. And then let's solve for S. Now, itong first order tsaka second order actually has something to do with poles. It actually indicates the number of poles of your system. A first order system would have 1 pole. Okay? While your second order system would have 2 poles. Okay? Is that clear?
Okay, sir.
Balikan nyo to sa
Yes po, sir.
Balikan nyo to sa topic 4, ha. Okay. Now, ang tawag dito? If your system is only a single pole system, if you have a first order system, we are assured na since isa nga lang yung pole niyan, we are assured that we take note that the response, okay? That the total response would consist of two components. Ano yung two components ng response niyo? Ang total response natin will have two components, always. Okay? So, ano yung dalawang components na yun?
Sir, ano ba yun? Yung reaction time? Tsaka
Hindi.
movement time ba yun?
Hindi. Medyo iba pa. Try ulit. Baka meron pa dyan, baka may lumabas pa dyan.
Sir, yan po ba yung transient tsaka steady state po?
Just yung transient tsaka steady state. Actually, yan, isang part yan. Okay, isang part yan ng pero yung transient response at saka steady state response is part of the total response. Okay, ibig sabihin, when you have a certain response output or response of a system, okay, merong certain period of that we consider the transient, okay, and there is a certain period of that we will consider steady state, okay, pero hindi siya yung totality ng response natin. We don't simply say that transient response plus steady state response equals the total response. Hindi ganoon. We don't say it that way. What we just say is that in the response of your system, there is a certain time, okay, that your response undergoes a transient, and there is a certain time that your response is settled. So yung part na settled na nag-undergo siya ng transient is that part of the response we call the transient response. While that part of the response na settled na yung response niyo is that the steady state response. Okay? But those are not the components. These two are not the components of your response. So ano yung components na tinutukoy natin? These two are intervals of time, okay, with specific characteristics ng total response natin. Okay, meron tayong sinasabing certain period of time na transient siya, meron tayong certain period na siya is steady state. Pero what I'm asking is, ano yung components? What are the components of your total response? Ito yung pag sinabi mong component 1 tsaka component 2, pwede nating i-add. Yan. Ano yung dalawang components na yan?
Ano po, sir? Forced response tsaka natural response po.
Okay. Meron tayo tinatawag na forced response. Force R na lang. Tsaka ano yung isa? Natural. Natural response. Yan yung components ng total response natin. Very good. Okay. So if these are the components, we know for a fact that this part comes from your input. Okay? You solve this using your input function. Kaya nga tinawag na forced response because it comes from the forced or the forcing function. Forcing function refers to the input to your system. While the natural response, okay, is inherent to your system. Okay? That natural response actually should include initial conditions. Pero sabi nga natin, sa context nga na nag-uusapan natin, we consider our systems to be relaxed. So therefore, wala tayong initial conditions na pinag-uusapan dito. Pero saan siya manggagaling? Nanggagaling yan sa system poles. The characteristics of your system poles. Okay? So, Ano nga ba yung gusto ko i-point? Ayun. For a single pole system, for a first order system or a single pole system, yung general format ng response ninyo is something like A plus B E raised to negative 80. Okay? Where A, yung small a, is the location of the system pole. Okay? That's the location of your system pole. Okay? Maliwanag?
Yes po, sir.
Ang tanong dyan, A at saka B e raised to negative 80. Alin dyan yung natural response, alin yung forced response?
Natural response, sir, yung A.
Yung?
Yung A.
Agree ba kayo doon? Ulitin ko ha. Ang natural response nyo, nanggagaling yan sa system poles. So merong influential system poles dito sa natural response. Yung small a na to is your system pole. So nasa na natural response ngayon dyan?
May exponential, sir.
Nasa B
Yung
pala,
exponential.
sir.
Yun, yung exponential. Kasi yun yung may system pole eh. Yun yung component ng may system pole. So ito yung natural response ninyo. This is your natural response. And this is your forced response. Okay. So for first order system, madaling i-predict yung yung C of T ninyo, yung response ninyo. Okay, because dahil nga isa lang naman yung pole ninyo, that means kapag in-inverse nyo yun, if you actually take the inverse of that response, okay, having a single pole, okay, mauuwi lang yun sa exponential. Okay? So basically, a first order response is an exponential response. Okay? And then we characterize now first order response. So characteristics of the first order response. Okay, we characterize your first order response using three quantities. Ano yung tatlong quantities that we use to characterize the first order response? Again, nasa topic 4 ito.
Sir, ano po, sir, is underdamped, critically damped, and overdamped.
First order First order.
Okay po, sir.
Yung sinasabi mo pang second order yan.
Ano po, sir,
Tsaka when you say
Force-
wait lang. Pag sinabi yung characteristics, these are characteristics of the first order response. These are your quantities. Quantities to. That would actually describe gaano kabilis yung first order response niyo. And when you say gaano kabilis, that means time. So how do you characterize your first order response? Say to
sir,
yourself,
yung po ba, sir, yung ano po, sir, force response, free response, tsaka po transient response.
Ito yun.
Po. Okay po, sir.
These are quantities. Number ito. Time quantities ito. So,
Ano po, sir? Time constant, rise
okay, you have the time constant. Tsaka, sige,
rise time po.
rise time.
Tsaka setting time.
And
Setting time, sir.
settling time. Settling yun settling. Hindi setting. Settling means magsasettle na siya. Okay? So it's settling time. Okay. And how do we compute this? TC? Paano siya kino-compute?
One over A, sir.
1 over A sa time constant. Rise time is computed as?
2.2 over A, sir.
2.2 over A. And settling time is
4 over
4 over A, sir.
4 over A. Very good. Okay? So, yan yung mga quantities that would characterize your first order response. Okay? So, wala kayo niyan sa quiz, di ba? Hindi niyo na ano yan. Pero actually, wala kayong first order response kasi sa, wala ba? Wala yata. Wala kayong first order response sa quiz niyo. Okay? Pero meron kayong second order response valid doon. Okay? So, ayan. Ngayon, punta tayo dun sa second order. Bakit ulit siya naging second order? Karilises ko lang yan kanina.
Nag-iba na po ng parameters.
Bukod doon. When do you consider your system to be a second order system? Balikan natin yung notes nyo kanina. Ayan.
Number of poles, sir.
Number of poles. Pag second order system, that means it has?
Mas marami yung pole ko.
Bali ilan?
2 po.
Yun. Second order means two-pole system siya. Okay. The system has 2 poles. Okay. Kaya second order. Now, contrary dun sa characteristics nung first order system niyo, which only has 1 pole. Yung 2-pole system ngayon or yung second order system ngayon has variations in response. Kasi kung 2-pole system 'yan, ito yung mga pwede niyong kombinasyon ng poles niya. Okay? Pwedeng ang poles niyo ay dalawang real poles. So P1 at saka P2. Okay? Pwedeng siya ay, lagyan nga natin ito ng pwede ko lagyan ito ng ayun. Kunwari magagamit ko yung rule lines na yun. Ayan. Kunwari magiging diretso yung drawing ko, no? Okay. So, pwedeng dalawang real poles. Okay. 2 real poles. Ayan. Maaari ding double pole sa isang location. Okay. So, you have a 2 real distinct poles. Okay. Ito naman, 2 real and equal poles. Ano pa? Ano pa yung pwedeng kombinasyon nito? Di ba? Wala. Pwede rin siyang complex. Naintindihan niyo 'tong ginagawa ko to? Itong dinodrawing ko? Is this clear to you? Okay. Ano to ha? Argand diagram to. It locates your poles or it locates your poles using J omega at saka sigma. So which means na halimbawa ito. Okay? Since real pole nga siya, okay? It means that 0 yung imaginary part niya. So therefore real number nga siya. If you have, say for example, sigma plus J omega na number, okay? Say and if this is 0, if your omega is 0, okay? So therefore may iwan lang yan sigma, a real number. Okay?
Yes, sir.
Yes, sir.
Okay naman tayo sa complex number natin, di ba? Okay, so ito, yung poles nyo dyan ay sigma plus J omega tsaka sigma minus J omega. So, yan yung case na you have a pair of complex poles. And kapag meron kayong complex poles, they tend to be conjugates. Okay? So, ibig sabihin, automatic na kapag meron kayong isang complex pole, meron yung reflection sa baba. It is reflected on the lower half of your plane. Okay? Or on the lower than this. Yung mas mababa dito sa sa x-axis niyo o sa sa sigma axis niyo o real axis kumbaga. So meron kayong pair of complex conjugate poles, okay? And then finally, meron kayong pair ng purely imaginary poles. Positive j omega at saka negative j omega. So meron kayong pair of purely imaginary poles. And of course, conjugates din yan. Again, kasi dahil nga siya ay nandito sa area na to. Okay. Ang tendency niyan, conjugate siya. Okay. Which now leads you to 4 responses. Okay. That would lead you to 4 types of responses para sa second order system. Ano yung 4 na yan? Kapag meron kayong 2 real distinct poles, ano yung classification ng response niya? O ng step response niya, bali?
Critical dump. Ay, hindi pala, hindi mo kasama yun.
Sige. Try mo i-correct.
Overdump lang po.
Yun, overdump. This is an overdump system. Okay? Pag naman equal sila,
Yun na po
real pero equal, siya ay
critically dump.
critically dump. Okay. Balikan nyo to sa balikan nyo to sa sa topic mo ra. Pag ito, this is
Underdump po.
underdump. Okay, and this is
Undump.
undump. Okay. Itong dalawang to, okay, pag titingnan nyo yung response graph niyan, actually yan, medyo exponential. Okay. Pero comparing these two, mas mabilis tong critically dump kaysa overdump. Kumbaga, kung yan yung overdump, if this is the overdump response, this would be the critically dump response. Ayan. Yung blue yung critically dump response. So mas mabilis siya ng konti kumpara sa overdump. Pero pareho silang mukhang exponential. Because basically, these two real poles, at saka itong real pole na to, actually produces exponential response. For example, in this case, ang magiging response nito, ang step response nito is basically A plus B e raised to negative P1 raised to T plus C e raised to negative P2 T. So, dalawang exponential terms yan. Okay. Pag re-wrap nyo yan, ganito itsura niyan. Yung kulay black. Okay. While ito namang two real equal poles, ang magiging response niyan is somewhat A plus B e raised to negative P1 times T plus C times T e raised to negative P1 T. Dahil nga repeated siya, okay, dahil repeated yung pole nyo, magkakaroon to ng factor na T dito. So that makes the response faster compared to this one. Okay?
So,
Maliwanag?
yung ba time yun? Yung inat.
Paano ulit? Sorry.
Yung inat po na variable po. Ano po ba?
Time din yan. Same thing ito. Saan to?
Pero magkaiba po sila.
Hindi, pareho yan.
Same lang.
Same yan. Same na time yan. Time parameter yan.
Same.
Actually, that makes it faster kasi once na yung exponential, i-multiply mo ng linear time. That hastens up yung pag-decay nito. Mas bumibilis yung decay nitong part na to kumpara dito. So kaya ang tendency, mabilis din mag-settle yung system mo. That's one thing that you have to remember about critically dump. Relative to sa overdump Pero basically, yung dalawang yan, ang response yan, mukhang exponential. Or it seems exponential. So actually, if you're just looking for on the response graph, okay, if you're just looking on the response graph and wala kayong idea kung anong system yung kino-consider with this response graph, you might be thinking na baka first order response yan. Okay? Which again, you should have to first to think whether ano yung system na ina-analyze. Okay? You don't conclude na first order response yan dahil nakita yung exponential yung response. Okay? Without having any knowledge about what the system is. Okay? So that's one thing that you have to remember. Now, diretso muna ako sa undamp bago tayo mag-proceed sa underdamp. So yung undamp, basically, okay, ang response niyan, ganito. Undamp siya eh. Okay, ganyan yung response niyan. Oscillating, nag-o-oscillate siya. So time ito, tapos ito yung value ng response niyo. So oscillatory yung response niyo. Okay? While sa underdamp naman, okay, in your underdamp response, okay, ang characteristic nito is its characteristic is okay. Meron siyang konting lagpas. We call this the overshoot. Okay, we call that the overshoot. Okay. Pero eventually magse-settle din siya on a certain value. Okay. So yun yung underdamp response natin. Now, in the discussion of in the discussion of this types of we have defined two parameters. Okay, we have defined two parameters of your second order system. Okay? Meron tayong define na dalawang parameters. Ano yung dalawang parameters na yan? That characterizes your second order system in terms of their general behavior. Dalawa 'yon.
Di ba sir yung speed?
Yung?
Speed of response.
Hindi yan.
Hindi po.
Try pa. Baka meron pang ibang maisip. Ano yun? Dinefine natin siya. Okay. By the way, ang general form ng ng second order system niyo is something like B over S square plus AS plus B. Ganyan yung general second order system niyo. Yung transfer function ng general second order system niyo. Okay. Then we have defined two parameters. Para actually ipapalit natin siya dito. Tapos that also helps us determine itong mga to. Depende dun sa value. Actually nung isa, pero dependent kasi din siya dun sa isa. So actually both of them would actually determine kung overdump siya, critically dump siya, kung underdump siya, and undump siya. So ano yung dalawang yan? Kailangan talagang balikan yung topic 4 ninyo, no? Nahirapan kayo sa finance yan kapag hindi nyo napagdugtong tong dalawan to. Damping ratio? Tsaka, ano yung isa? Ano yung kapartner nitong damping ratio?
Natural response, sir.
Hindi, natural. Natural ano? Hindi response natural.
Frequency, sir.
Yun, natural frequency. So you have natural frequency tsaka damping ratio. How do you compute natural frequency? Galing dito
Square root ng B, sir.
This is square root of B. And then, damping ratio is?
A over
A over
2.
2
Yung WB.
omega N.
Kasi N pala.
Okay, so this is how we compute this, these two things. Okay, kaya we can rewrite this, we can rewrite this as omega N square over S square plus 2 dr omega N S plus omega N square. Okay, we can rewrite this general equation into this form. And again, tulad nga sinasabi ko, makakarakterize itong apat na to using the value of your dr. So how do we do that? For example, ang overdamp, pag ang dr mo is greater than 1, you say that your system is overdamp. How about pag critically damp siya? Anong value ng dr natin?
Equal lang sa 1, sir.
This is equal to 1. Pag underdamp,
Ano, sir? Less than 1.
less than 1 and
Greater than 0.
greater than 0. Okay? Then pag undamp,
Zero, sir.
0.
dr is equal to 0. Ayun. Actually, these names, undamp, underdamp, critically damp, at saka overdamp, can actually be remembered from this. Okay? Thinking na yung, for example, undamp. The damping ratio is 0. Undamp kasi, walang damping. Undamp. Okay? Underdamp siya if the value of your dr is less than a certain critical value. And that critical value happens to be 1. So if your dr is a fractional number, so that makes it between 0 and 1, okay? Your system tends to be underdamp. Okay? While pag mas malaki naman yung damping sa 1, okay? Then your system is considered overdamp. So pag nasa threshold siya, which is 1, yun, critically damp siya. So as you can see here, if you are actually increasing your dr, okay? If you're increasing your dr from 0, okay? If the value of your dr is actually increasing from 0, okay, and increasing, okay, your response proceeds from being oscillatory to losing its oscillation and settling for a certain value, okay, to being exponential. Dito muna siya sa blue, tapos tsaka siya magba-black. Okay? So, ganun yung evolution ng response niyo once na ini-increase niyo yung dr. And the movement of your poles is ganito. Pag yung dr niyo ay 0, nasa imaginary axis yung poles niyo. And napupunta yan dito sa real axis as you increase your dr. Okay? So habang ini-increase niyo yung dr, napupunta yan dun sa sa real axis. So kailangan niyo ngayong maalala to kasi we will have to relate later on in this particular topic 5. we will have to relate these quantities, okay, into those movements suppose niyo. Okay, and later on pagdating sa sa system design, okay, you would be needing those knowledge, okay, when it comes to moving your poles and how does it affect yung value no diat niyo. Okay? Is this clear?
Yes, sir.
Ngayon, in topic 5, okay? So ito yung topic 4. Yun yung pinag-usapan sa topic 4. Okay? In a nutshell, yun yung pinag-usapan sa topic 4. Yung topic 5, magko-concentrate tayo dito. We will give emphasis, okay? We will give emphasis to to those systems having underdamped step responses. Okay? So yun yung pagtutuunan natin ng pansin dito sa topic 5. Okay?
Yes, sir.
So again, sinabi natin na ito yung this is the underdamped the general second order transfer function, okay? In which kapag kinumpit natin yung step response niya becomes this one. Okay? So the general form of the step response of an underdamped system is this one. So that involves an exponential multiplied to a sinusoid. Okay? Pag meron kayong exponential na multiply nyo ng sinusoid, pakita lang natin as an example lang din. So dito, nagbubukas lang ako ng graphing tool. Nagutom na ako. Di pala ako nag-lunch. Nakalimutan ko. Okay. Ang gusto ko ipakita dito is ano yung epekto kapag nagmultiply ka ng exponential sa isang sinusoid. Okay? So, bigyan tayo ng mga particular examples, no? Say for example, this is your sinusoid. So, cosine say 40. F1. Sabi natin, F1 of t equals cosine 40. So, yan yung itsura niya. Okay? Yan. Lagyan natin siya ng para alam natin na walang value when t is negative. Okay, so this is how your sinusoid looks like. Once na or this is the pure sinusoid signal that we have. Okay? Now, this is your exponential. Say for example, e raised to negative 0.2 t. Halimbawa. Okay. So you see na meron kayong exponential dito that actually decays. That's the blue graph. Okay? You understand this? You appreciate this these graphs?
Yes, sir.
Yes po, sir.
Okay. Tingnan nyo ngayon pag multiply natin siya, I'll have f of t equals f1 of t times f2 of t. Okay, patayin ko itong dalawang to. Tingnan nyo. So as you can see, you now have here a graph that eventually decays. Okay. So nakita nyo nagde-decay yan, paunti-unti. Okay. So yan yung exponential multiplied to a sinusoid. And if you can observe, i-overlay ko yung exponential. Okay. Yung peaks nung sinusoid niyo. Okay. Nung decaying sinusoid niyo, actually follows that of the decaying exponential. So, natin to i-screenshot natin, lagay natin sa notes ninyo. Let's put it here. So, ayan. Nalagyan natin ng annotation, no? This blue line, okay? This blue line represents your exponential, e raised to negative 0.2t. Okay. While this, yung black nga yung gamitin natin. So, this blue line, okay, represents your e raised to negative 0.2t. Tapos itong green line, represents your product, e raised to negative 0.2t, cosine of 4t. Okay? So, as you can see, this graph is actually a decaying sinusoid. It's a decaying sinusoid, no? Okay?
Yes, sir.
Ang specific na tawag natin sa decaying sinusoid na is actually a damped sinusoid. Okay? So in underdamped responses, okay, in underdamped responses, since meron kayong term, sorry. There is this term that you have here. Okay, there is this term that you have here as the product, okay, itong itong factor na to. Okay. It's actually a product of an exponential, okay, and a sinusoid. So when you multiply these two, when you multiply exponential and sinusoid, it becomes a damped exponential. Or I mean a damped sinusoid. Okay, basically it's a decaying sinusoid. Pero actually kung magde-decay siya, depende actually sa exponent niyo. It actually decays because the exponent is negative. Okay? But if that exponent is positive, tingnan niyo to. If that exponent is positive, say that one. Okay. Instead of decaying, your exponential actually grows. Like that. I mean, your sinusoid pala actually grows. Okay? So, nagde-decay lang siya because the exponential is negative. Is that clear?
Yes, sir.
Okay. And,
Yes po, sir.
Yes, sir.
and going back dun sa growing sinusoid. If your response contain something like that, okay, if your response contain a component that grows like that, okay, it's actually a signal that it's actually a sign, okay, or a symptom that your system is unstable. Okay? Because it would lead to a very large response later on. Okay? That is why for a system to have a usable response, or for your system to be usable overall, okay? And if it has to be an underdamped system, dapat yung exponential niya negative. O yung exponent ng exponential factor niya should be negative. So that meron kayong meaningful response or meaningful output for your system. Is that clear?
Yes, sir. Sir, may tanong lang.
Sige, sino yung may tanong?
Yung, doon ba, kunwari, sir, yung sa positive, yung lumaki, ano yan, sir? Sa system, nagkaroon ng disturbance sa noise?
Ito kasi, pansinin nyo mabuti ito yung sagot sa tanong mo, ha? At saka magandang tanong yan, actually. It's a very good question. Ito kasi yung paggagalingan ito yung paggagalingan ng term na yun. Okay? This actually determines whether your response is decaying or growing. Okay. So that is that factor is negative dr omega n. Okay? This dr omega n, this product dr omega n. Okay. Kung ita-trace back natin ito kung ita-trace natin ito pabalik, galing dito papunta dito, ita-trace natin siya dito. Kung ano yung kinalaman nitong negative dr omega n na yan. This actually corresponds to the real part of your pole or of your system pole. Okay? It actually corresponds to the real part of your pole. Hindi mo natin siya ipapakita ngayon. Okay? I won't be deriving this right now. Okay? Pero alam ko dun sa video na ipaprovide ko sa inyo for topic 5. Merong discussion ito about doon. Okay? Pero later on din kasi dito sa topic 5, pag-uusapan din natin ulit siya. Okay, pag-uusapan natin to kung saan nanggagaling tong dr omega n na to. Pero basically, sa ngayon pa lang sabihin ko sa inyo, that dr omega n is the real part of your pole. Okay. So which means, kung ito yung location ng pole natin. Okay. If that is the real part of your pole. Okay. Kasi yung pole nyo sigma plus or minus j omega para sa underdamped system. Okay? Ulitin natin Para sa underdamped system, ang layo na pala. Okay. Para sa underdamped system, ang poles ninyo, okay, sigma plus or minus j omega. These are the location of your poles. Okay? Nasundan?
Yes, sir.
Okay. So, kung yun yung natin, kung yun yung location ng pole natin, itong sigma na to, ito yan, yung dr omega n ninyo. So, pag yan ay negative, pag yung real part ng pole ninyo ay negative, malolocate nyo yung pole nyo dito, sa left side nung nung graph ninyo, nung S-plane ninyo. This is your S-plane Okay. Malolocate nyo yan, kung negative siya, malolocate nyo yan sa left side. Tama ba?
Yes, sir.
Kasi ito yung sigma ninyo This is your sigma. So dito, sa eksaktong line, sa eksaktong y-axis, that your sigma equals 0. So ibig sabihin sa kaliwa niyan, that is when sigma is negative. Tapos sa kanan niyan, that is when your sigma is positive. Okay? So ngayon, kung negative tong real part ng pole niyo, nandito siya sa kaliwa. Okay? Kung positive yan, nandito yan. Let's use a different color. Nandito yan sa kanan kapag positive siya. Okay. Now, going back to my point. Again, ito may kinalaman to sa system pole. This has something to do with the system pole. Okay? If your system pole, okay, is actually located on this on this side of the S-plane. Okay. Again, if your system pole is located on that side of the system, of the S-plane, basically we call this side of the system the left half plane. Okay, yung sinigdan ko na yan ng kulay blue, ang tawag natin dyan, left half plane. If your system poles are located on that side, your system is considered to be stable. Okay? And therefore, would have a response na ganito. Okay? So, ganito. Your question was, ito bang term na to, itong number na yan, has something to do with noise or something to do with disturbance or something like that?
Yes, sir.
Yung part na yon is wala pa. Okay, wala pa siya dun sa wala pa siya dun. Yung disturbance or yung noise, does not determine kung yung term na yan, yung point 2 na yan is positive or negative. Wala pang kinalaman yung noise at saka yung yung disturbance. Okay? Sa ngayon, ang pinag-uusapan pa lang natin, system pa lang. Okay? So, if your system itself has system poles that are located on the left half plane, okay, then we can expect that your system would have meaningful response because it has a decaying sinusoid or decaying damped sinusoid, okay, and therefore is considered stable. Pero hindi ko sinasabi na walang hindi natin sinasabi na hindi magpe-play ng role yung dito, yung noise and disturbance. Ang point ko is, kahit na stable yung system niyo naman, okay? Kahit na stable yung system niyo. Okay. There are some factors, okay? There are some factors that would actually lead your system, okay? That would actually lead your system to be unstable, or to give unstable responses, or to give responses that are growing. Okay? Pero walang kinalaman yung system doon. Ang may kasalanan na nun, yung disturbance at saka yung noise. You get my point?
Yes, sir.
Sir. So,
Okay. Sige. So, ganito kasi, di ba? Balikan ko lang yung point kanina. Di ba ang city is natural response plus forced response. Okay?
yes, sir.
Pag ang system nyo ay stable, okay? Pag ang system nyo ay stable, ibig sabihin, okay to, yung natural response nyo. It means, natural response becomes 0 as your time approaches infinity. Habang tumatagal yung measurement natin, yung natural response niyo nagde-decay sa 0. So pag ganyan, stable yung system niyo. Okay? So, ganito. Pag hindi nangyari ito, ibig sabihin, if your natural response is not 0, okay, as your time of measurement grows large, okay, yung system nyo nagiging unstable. So that would lead to a response na palaki. Okay? Palaki. As time progresses. Okay? So, yun yung isang dahilan kung bakit system itself. Okay? On the other side, again, natural response plus forced response. Okay? Pag ito ay naging 0 as time approaches infinity, okay, or as time grows large, okay, stable siya. Pero, pag pinasukan ng noise or disturbance, yung system ninyo, i-account natin yan sa forced response, not the natural response. I-account natin siya doon sa forced response. Kasi input yan eh. Okay? Most especially kung ang disturbance na pinag-uusapan natin ay external. Okay? Yung external disturbance na yun are considered inputs to your system. Bukod pa yan doon sa talagang input ninyo. Okay? Your input, the input to the system itself plus the disturbance constitutes the inputs to your system. And those determine forced response. So ngayon, kung yung forced response niyo ay lumalaki, okay, because of the disturbance, then it would lead to a city that grows large. Pero in that case, we don't say that your system is unstable. In this case, we don't say that your system is unstable. Kasi wala namang kinalaman yung stability ng system sa paglaki ng city. Okay, you get my argument?
Yes, sir. Yes, sir.
So, yun yung kailangan natin tandaan dito, no? So, merong ilang dahilan kung bakit yung response ng system niyo lalaki. Okay. Pag lumaki siya dahil sa system, malaking problema 'yun. Kasi yung system ang may problema eh. So, kailangan niyo palitan yung system. Pero kung may problema, yung
Input lang, sir.
yung input lang,
Walang problema. Oh.
may konti siya problema kasi ibig sabihin nun, yung system mo naman hindi nag-a-adapt dun sa dun sa disturbance. Pero makukuha 'yun by tweaking the system. Pag medyo nire-design mo ng konti yung system mo, baka kahit na malaki yung disturbance, makompensate niya 'yun. So posible 'yun, posibleng mangyari yung ganun.
Okay, sir.
Okay. Pero kapag ang system nyo unstable, yung system nyo ang dahilan kung bakit lumalaki yung response, kailangan nyo palitan yung system nyo. Yun. Okay? So, ganito ha. Hindi, baka sige ganito. I'll see if on Tuesday we will have a meeting. Okay. Pero ipo-forward ko sa inyo yung yung reading materials as well as the recorded lecture para sa topics 5.1, 5, 6 at saka 7. So again, yun ang magiging sakop ng quiz number 2 natin. Okay? So sige, dismiss na tayo kasi overtime na ako ng 2 minutes eh. Baka may klase pa kayo. At saka ako pala, may klase pala ako. Okay, so sige. I'll see you next Tuesday siguro.
Thank you, sir.
Thank you po,
Okay.
sir.
Sige.
Thank you po, sir. Thank you po.
Thank you, sir.
Thank you din. Sige. Paano lang, palid na ng meeting ha. Thank you.